Another major manufacturer in Texas for a long, long time, Bell Helicopter, Mr. Michael Thacker, Executive Vice President for Technology.
Well, I also appreciate the invitation. It's an honor to be able to speak to this gathering of esteemed minds from the state of Texas. However, having talked with a few of you at the tables earlier, I think it may be worth a little bit of an introduction of who we are. Bell Helicopter is a part of Textron, which is a larger consortium that also includes some military applications with Textron Systems and Textron Aviation, which many of you may know as Cessna and Beechcraft, that have been put together into one company today. And I spent many, many years there before making the transition to Bell. Bell in Texas, of our little over 7,000 worldwide employees, almost 5,000 of those are in Texas. And our primary headquarters is in Fort Worth, but we have facilities in Amarillo, in Arlington, and in other locations to be able to design, build, deliver, and support helicopters and military vertical lift products around the world. Today, you may be familiar with some of the products you see on the page. Commercial helicopters from light entry-level helicopters all the way through medium twins, and military products including the iconic Bell H-1 and the only vertical takeoff and forward flight vehicle in service today, the V-22. When we are moving to the future, things that are currently in flow, the Bell 505 recently entered service. This is a light helicopter, kind of reestablishing the price point for being able to enter into a turbine helicopter. And while that may not sound like a great deal, it does take science, innovation, and engineering to take a product that had escalated in price to over $2 million, effectively pricing out of a market, to reinvent it with modern technology, a Garmin glass cockpit, new materials, updating the manufacturing process to be able to get that back down in the $1 million range where you once again have an affordable and saleable product. The center product and certification today, the 525, will be the first commercially certified fly-by-wire helicopter. And on the right-hand side of the page, some of you may be familiar with the V-280 Valor, which recently had its first flight and is continuing its flight test program to be the next generation future vertical lift for the Army. So, like many companies that have been around for over 80 years, at times you have to reinvent yourself or perhaps go back to what you once were. The person you see on the stage there is my boss, Mitch Snyder, and he took over the role of president and CEO of Bell a couple of years ago. And one of the first things he did was kind of reintroduce the idea that Bell needed to get back to its roots. Products and activities had stagnated to some degree, and he wanted to get us back to rapid innovation of new products to excite both the commercial and the military market. And in some sense, that's the challenge. Rapid and innovative at the same time in a world that continues to move at an increasingly accelerated pace. Here are a few of the things, and I'll talk about some of these as we go through the presentation quickly, but Bell has a history of innovation that we, to some degree, got away from. Some of you may not know, but the first supersonic aircraft was the Bell X-1. We've been doing transformational flight since the 60s. The first jetpack was a Bell long before anyone even thought about a movie for Iron Man. So we've been an innovative company, and one that took things rapidly, not quite recklessly, into the air, and we needed to get back to that. So we talked a little bit about the products that are in flow today. Some of the challenges that we face are being able to modify existing products to do things that they couldn't do before. So augmentation on a path to automation to take high-risk flight on existing products and make it low risk. Not taking the pilot out of the loop, but minimizing the things that he has to do in a heavy pilot workload environment to make that a safer and more operable and maneuver, and then transitioning that over time to fully automated flight. Radical new vertical lift technologies with, for instance, advanced anti-torque that both is a radical improvement in terms of noise but also safety when compared to an open tail rotor. The ability to have situational awareness for both existing platforms and for unmanned platforms of obstacles that may or may not be in your charts. And as we get more and more of these in the air, to be able to understand where those obstacles are, whether they're sending you a signal or not. So it's a bit of the fusion that was talked about for the F-35, but in a commercial environment where you need to be able to sense the obstacles, you also need to be able to get the communication from that, fuse that together to get a clear picture of the environment you're operating in, and then avoid collisions and make good decisions. Rapid ability to prototype, to test, to validate with modular test platforms. Radical new vertical lift opportunities in unmanned flight. There's a huge opportunity out there today in the commercial world, whether it's in logistics for moving packages from place to place or even to your doorstep, or I was just at CES earlier this week unveiling the Bell Air Taxi, where we are partnering with Uber to bring to a neighborhood near you the future of flight, where you'll be able to, at a reasonable and affordable cost, get across town, avoid traffic, and be able to do that in a safe, reliable, dependable way. Advanced propulsion. Propulsion has always been one of the keys to advances in aviation. I'm excited about the idea of fusion. That could be very useful if we can package it small enough to fit in our products. But in today's world, electric propulsion, hybrid propulsion, and the idea of distributed propulsion are coming together in a way that's allowing the creation of new products that were never envisioned before because the mechanical propulsion that was behind it couldn't support it. Manufacturing technologies are a key as well. Additive has become somewhat ubiquitous, but at the same time, it's not readily available in aerospace because we don't have all of the allowables required to put it into certified products in every application that we would like to. So it's materials, but it's also having them reliably produced and producing both cost and weight benefits. Augmentation, whether it's augmented reality or virtual reality, implemented both in the products themselves, perhaps helping augment the pilot and provide them with advanced situational awareness, but also in the workplace, doing maintenance, doing the fabrication of the product to start with. Advanced vertical products like the V247 that you see here, and then rapid prototyping. Again, the V280 on the test stand was faster than Bell has ever done this kind of a program before to meet a military customer's demand. When you think about what all those things are showing, there is a convergence today of the digital and the physical world, the virtual and the physical. You may have heard of the idea of a digital twin. And the idea here is that it's great to have mechanical engineers, it's great to have software engineers, but the reality is for our business, we need people who can do both. And so when we talk about some of the things that we need to do, one of the things that Bell is doing with our engineering workforce is bringing in mechanical engineers and putting them through coding school and control school to teach them how to be both understand the physics and understand how to digitally represent that and create that integrated product that we really need. And we're bringing software engineers in and we're running them through Helicopter 101 and teaching them the physics so that they can do the deep coding but have enough of an understanding of how the business really works to interface with the rest of the team. The idea of an integrated product team was great, but if all you have is deeply rooted experts, they have trouble communicating with each other. We need the bridge. And so from an academic standpoint, particularly in your undergraduate programs, for the academic institutions, that's something that we would like to see. When you think about what else you can do, I guess the first thing I would like to say is there's a lot of great work going on. Over the past, I would say 5 to 10 years, academic institutions, particularly in engineering, have moved to more experiential learning, getting a little bit away from the pure theory and helping people really understand how to apply the knowledge that they've gotten. Industry has desperately needed that, and so I laud academia for going along that path. The institutions are also working on many of the problems that I just mentioned, whether it's really understanding the science of how do I make a LiDAR on a chip to be able to have something that's small enough, lightweight enough, and low enough power consumption to make it make sense for a small unmanned vehicle that needs that kind of capability to operate in an airspace. Those types of things are happening at universities and laboratories today, and those are the kind of fundamental science that we need to be able to integrate into our products. So there's a lot of good work going on, but we need a bit more of it. We need to really think about the man-machine interface, and we need to think about it not just in the physical product of how does the pilot interact with the machine, is there a pilot, is there an operator, but we need to think about it in terms of how we do our work. How can we really optimize, not to recreate the human brain in the digital space, but how can we take advantage of what people do well and what machines do well and optimize that interface not only in the engineering space, but also on the factory floor. In this kind of an environment, we like to talk a lot about the technical piece of it with the engineering operations and the science, but in the end, we have to build the products as well, so we can't forget about the factory floor. From a state standpoint, that's a critical piece. Our workforce is an aging workforce, and the skills that they have are great for the products that we designed 30 years ago and built 10 years ago and may still be building today. But we need that mixed digital skill set where you could work in parallel with the machine for the future, for the next decades, and we need to be developing that building workforce as well as the designing workforce. So that's what we really need from the state, from my perspective. And finally, we need inspiration. You know, it's interesting that Dr. Aldrin is here. I was born when the lander was landing on the moon. The doctor wasn't there. He told my mom, "You'll have to wait. I'm going to watch this." And I was told that story from a very early age. My dad was an Air Force guy, but those are the sorts of things that inspired me to become an aerospace and aviation professional. We need to inspire the next generation. The great videos from SpaceX can help to do it. Really interesting products like air taxis can help to do it, but we have to tell our stories, and we have to do it in a way that relates to this generation, that can be consumed by video games, might be excited by Google, but we need that talent in aviation. So we've got to tell our story. So if you guys can do that, I think that together we can make it a brighter future. Thank you.
Thank you very much, Michael.